Well, good morning, class. We're looking at section 3.1.4 for our second day, and there's four problems we're going to complete, starting with question 41. And it says Evan has graphed the point 5, 7 over 5 up 7, and he wants to reflect it over the line y equals negative 2/5 x plus 6. He predicts that the reflected point will have the coordinates at 2, 2. Without graphing this, can you confirm his answer or show that he cannot possibly be correct? Explain. And I'll just point out that this diagram, they say, is a sketch. It's a crude sketch. We're told that this is roughly the point that he graphed, right? This was the over 5 up 7. Yeah, over 5 up 7. This is the point 2, 2. And he thinks that this is a reflected. And if you think about what you did yesterday, when you reflect things across things, certain things should be true. So I'm just going to encourage you to think about this. And once you think you have a response, and you can work with others too to discuss this, but once you think you have a response, I'm going to have you just kind of type it on this slide right in here. So just put a response to this question. Just using the text tool, type something in this location. All right, next question we have. Definition of a translation. The formal name for a slide is a translation. So what exactly is a translation? Remember, there's two words at play here. We've got a transformation, and there are three rigid transformations we're considering. One of the transformations is a translation. So translation and transformation are different words. In this diagram, triangle A prime, B prime, C prime at right is the image of ABC. So you can see we started with ABC, we subjected it to a translation, and we got this image. Describe the translation, that is, how many units to the right and how many units down is the did the translation move the triangle. So if you look at it, if I look B, B, A, C, C, everything's still in the same orientation. So this was not a reflection across the y-axis. This is not a rotation. It's a translation. And you should be able to answer A pretty easily. How many units did X change? How many units did Y change? The next problem, I have a tool set up for you. It says on graph paper, plot EFG with these coordinates. What are the coordinates of E prime, F prime, G prime if triangle EFG is translated the same way as a triangle ABC was in part A? So to help you get an image for this and to teach you how to do translations in GeoGebra, I've set up some extra tools and I've taken away some. This first tool is called a vector. And basically a vector has a starting point and it's a directed distance. So if I was to click here, I could select the end point and the beginning point rather, and then the end point. So if you look at it, this vector is saying that everything on the Cartesian coordinate plane is going that I subject to this vector is going to be shifted 1, 2, 3, 4, 5 units to the right. So if I take the triangle from this problem we're looking at, I could subject it to this vector. And to do that, I use the translate tool. So this is the second one over. It says translate by a vector. And the directions below say select the object to translate and then select the vector. So I'm going to go ahead and select first the object that I want to translate, this circle. So I click, or triangle, I click in it, and then I click the vector. And you can see that this entire triangle was just slid 6 units. Was it 6? 1, 2, 3, 5 units to the right. So I was at 1, X was at 1, it moved to 6. X was at 4, it moved to 9. Here X was 1, it moved to 6. So everything was slid. Now this is a live vector and the translation is live also, meaning that I can come in and I can, I didn't want to do that. meaning that I can grab this point and I can change the translation, right? So you can see every single time I move the translation, it's just doing something slightly different. So now you can see I'm going over 1, 2, 3, 4 units, and I'm going down 1, 2, I'm going down 1, 2, 3, 4 units. Oh, so this is over 4, down 4. So this tool would be great for doing this problem. The problem does say something about drawing segments that connect an original point and the translated point. So you could use the segment tool to do this as well. And you should be able to answer those questions quite nicely using this tool. Once you have an image that kind of summarizes this, go ahead and screenshot that and include it in your work. And in your work, you should be able to answer A on this page quite nicely by describing how many units to the right and how many units down. On this page, this is a link to the tool that we were just looking at. If you click it, you can activate it here. And I think that you can do a nice job of answering A, B, C, and D. I don't think that you need tracing paper. I think you're going to get a pretty good idea of what's happening by looking at GeoGebra and doing translations on that plane. Let's go on to the next question. The next one's going to be question 43, and it says connections to algebra. The first thing it asks us to do is to read the math note box in this lesson. So let's take time to do that together. After taking a great stab at defining some transformations yesterday, I think we're going to go ahead and formally do that here in the math notes. So it says, in chapter 1 you learned that a function assigns input to assigns each input a unique output. Most of these functions involve equations such as f of x equals 3x minus 5. So in this case, if I put 2 into that function, I would get the number 1 out because 3 times 2 is 6, 6 minus 1 is 5. So you can see I give it an input of 2, it gives me an output of 1. In this chapter, you're studying functions that assign each point in the plane to a unique image point in the plane. These functions are called rigid transformations or motions. This is beautiful. This is amazing. This is great. So, wow. So, because they move the entire plane, the entire sheet of tracing paper with any figure you have drawn so that all the figures remain unchanged. Therefore, angle measures and segment lengths are preserved. They're preserving transformations. We keep the x and y axis on the underlying plane in their original position for reference. There are 3 basic rigid transformations that we will consider: reflections, translations, and rotations. All rigid transformations can be seen as a combination of them. Reflections. When a figure is reflected across a line of reflection, such as the figure at right, it appears that the figure is flipped over the line, looking like a mirror image. The mirror line is a line of reflection, shown as line L in this diagram, right here L. However, formally, a reflection across a line is defined as a function of each point A to a unique point A prime, so that the segments connecting the points and their images, such as A prime, is perpendicular to the line of reflection. So when I reflect across, right, I'm forming right angles, and it's showing that with this square angle here. And the other thing that happens is that when I do a reflection, the distance between an original point here, if I consider this point A, and its reflected image A prime, those distances are equal to each other. So we see 2 things are happening. When we reflect and connect a point with its image, this line segment that connects them will be perpendicular to the line of reflection, the line that we reflect across, and these distances will be congruent. Beautiful. It says both of those things there. Rotation, turning. Turning a figure about a fixed point is called a rotation. Figures can be rotated either clockwise or counterclockwise. Formally, a rotation about point O is a function that assigns each point P in the plane a unique image point P prime. That's what it does. It's just a function, right, that's moving the points P to a new location. So that all angles of rotation POP, all angles of rotation POP have the same measure, which is the angle of rotation, and OP will equal um, OP prime. And we saw this yesterday. If we're rotating the plane 30 degrees clockwise, right, this angle will be a 30-degree angle. And it will always be the case that if I was to measure the distance from P back to this point of rotation, and then from P prime to this point of rotation, these line segments will not change length. Those will always be congruent to each other. I think the thing that I'm focusing on most is the fact that where it says formally a rotation about point O is a function. It's a function that assigns each point P in the plane to a unique image point P prime. Beautiful. And then finally a translation. A translation is like sliding a figure. Formally, a translation is a function that assigns each point Q in the plane a unique image point Q prime. By the way, these names are just completely arbitrary. It doesn't matter that it's Q and up there they were calling it P. It's just saying take any point Q and a translation is going to assign that to a new location Q prime. So that all segments connecting a point with its image will have equal length and be parallel. So when we draw these, right, these segments, this segment, this segment, this segment, and this segment, those are all going to be both parallel to each other and equal in length. Q represents the original point, and Q prime is where it was moved to. And you can see there were 4 points on the original shape, right? We have this vertex, this vertex, this vertex back here, and this vertex cube. And all of those green ones are moved to new locations that I'll just mark in red. And you can see that beautifully in GeoGebra when you were doing the previous question. Okay, so we were asked to read the math notes and consider them, and we've done this. It says, note that the formal definitions of transformations involve functions. Yes, they do. They involve functions. They take something and move it somewhere else. So at this point, I'm going to leave these things for you to do. Just a bit of notation I want to point out that we have the points A, B, and C here. And we're going to subject these coordinates 3, 3, 1, 1, and 6, 1 using this function. If you look at this, xy is going to go to the opposite of x, the opposite of y. So we need to graph these points, and you can start up your own copy of GeoGebra and do that if you wish, or just do it on the graph I've provided in the slide deck. Subject these points to this rule and label the A prime, B prime, C prime. And then, so they're saying, for example, if one of your original points was this, it would have an image point where x was 8, so it's going to become the opposite of that. It'll be negative 8. And y was negative 3, and this says y is going to become the opposite of what it was, so y will become positive 3. After you're looking at, the question is, what single transformation is the function in part A? So you know 3 transformations. You know rotation, translation, and reflection. Which single transformation can be shown by this rule? Another one that they would like for you to do is this. The function rule, this goes to this. Use this to transform the triangle ABC again. So we're going to go ahead and take this triangle and transform it again, and describe the transformation or sequence of transformations that move this thing to this. And then finally, on a new set of axes, so not the original one but a new one, plot and connect the points to form quadrilateral WXY. If its vertices are here, right, quadrilateral WXY is transformed by this function. X is going to go to the opposite of x, and y is going to go what y was. And this is a slightly different take on the same notation. If you'll notice, they just switched it a little bit. You could write the same thing this way. You could say that x, y's are going to go to, they're going to go to the opposite of x, comma, and y's are going to stay the same, right? And then this question is, what transformation would map the quadrilateral wxyz to its image? So if you look at the point of 43 is to have you think about these things in terms of these function rules, right? Here is a function that maps a point to a new point. Here's another one, a point to a new point, and another one we're mapping a point to a new point. And the question is, what are those functions equivalent to? Which of our three transformations are they equivalent to? So I have set this up so that you do have access to this optional tool if you choose to use it. It would, I think, it help your presentation much better if you had, well, you're going to need to plot these with some weird graph that you bring in here and do this translation, or you can use this tool which would allow you to plot some points and then subject it to this rule. And by that I don't mean that it's going to do the transformation for you, because you're not sure which transformation this is. But once you've plotted the point 3, you can plot a new point and and uh, and then track what's happening with those two sets of points, the original points and the one that results after this function is applied. The last question is question 44, and it says facts about isosceles triangles. How can transformations such as reflections help us learn more about familiar polygons? Consider reflecting a line segment across a line that passes through one of its endpoints. So you can see here's this line BC, and we're going to reflect AB across that. So copy the diagram, and actually you don't need to copy the diagram. It's totally fine if you just use the drawing tools in slides to do the reflection here. In fact, one of the things you can do is if I was to draw a line segment, oops, in slides. So I've tried to estimate this segment right here as being equivalent to AB. And if I wanted to reflect this segment in slides, I can come over here. Nope, I can come to, where is it? It's to tools. No, it's not in tools, it's in arrange. So if I go to arrange, I see rotate. And interestingly enough, not everything here is a rotation, right? They've got rotate clockwise 90, counterclockwise 90. But if I want to flip this thing vertically, boom, right? It just took this shape that I copied and it flipped it, so I can bring it up there and look at it. Okay, that's it. Again, a lot of points in this section, right? Yesterday was 10 points for 314 day one. This is 10 points also. And plus there's the 5-point homework assignment that is due tonight. I hope most of you noticed that you have had the chapter 1 test preview delivered via the stream yesterday. It's not an assignment. It's highly recommended that you do that and that you watch in the stream for solutions to that. Today, I believe I said I would post those, or Wednesday. But it's just one of the tools that you can use in preparing for your test this Thursday, Friday. This is Ms. Roberts. Hope you have a great day, and I'll talk to you later.